Hello everybody, my name is Aditi. I'm from Team Horcruxes. We're participating in the FTC competition. Today I'll be presenting FMEA, which stands for Failure Mode and Effects Analysis. So what is FMEA? FMEA is a process used to identify failures in a system, such as a robot, a car, a cake, the causes and effects of these failures, and we prioritize them based on how significant their effect on the system is. So what does this help us in? So we this helps us in predicting potential failures before they occur, and we do this in hopes of having as less failures as possible, or at least reducing the frequency of these failures so that we could lower the risk of the overall system failure and increase the reliability of the system and its performance. So we have stages of FMEA. So on your right, you can see them. So the first is the failure mode. So what is a failure? Like a failure is the inability of a system to perform its intended function and meet the requirements slash expectations. For instance, your robot, like you expect the robot on a playing field to move around the playing field, but the robot falls over and topples. So it doesn't keep up to the expectation. So we consider that a failure. But the point of discussion is that would you really consider that to be a failure? Like, is the fact that the robot toppled the failure, or is the failure that the positioning of the heavy parts on the robot was incorrect? So, what would be the failure? The positioning of the parts or the fact that the robot toppled? Then we have the effect. This is the second stage. So the effect is basically what happens because of the failure, and in this case, the impact of the failure on the robot, which is that the robot falls. So in our case, the effect is pretty visible. But if we take another example, like a cake, so if you're making a cake and you're meant to add like 5 grams of sugar, but instead you add 20 grams. So your effect over here would be that there's too much sugar. So when you taste the cake, the effect is very visible. Like it's noticeable. You can say that there's too much sugar in the cake and it's too sweet. But say that you're meant to make a cake that is like 20 centimeter in diameter. Like the diameter of the cake is 20 centimeters, but the cake is actually 18 centimeters. So the effect in this case is more or less invisible because you can't really tell, it's not that noticeable. So the next stage is severity, which is the intensity of the failure. And in our FMEA document, it's a value out of 10. So the greater the severity, the more important the failure is. Then we have occurrence, which is the number of times the failure occurs. It's again a value out of 10, and the more frequent the failure occurs, the higher the priority. Then we have detection, which is how easily the failure can be detected. And this is again a value out of 10. But in this case, the easier to detect, the lower the priority. So for example, if your robot topples, it's pretty easy to detect that the robot toppled. So the priority of the failure reduces. RPN is the risk priority number. This is a multiplication of your severity value, your occurrence, and your detection values. It's out of 1,000. So now the greater your RPN, the greater the impact of the failure on the system, because when your RPN number is high, your failure is more severe, it is occurring more often, and it is also detected frequently. So this makes like your failure a threat to the overall well-being of the system. So that's why the priority to solve this failure is important. And how do we solve it? First, we identify the root cause, like why did it happen? And I just want to highlight the difference between a cause and a root cause by an example. So, say you're a worker in a factory that manufactures toy cars. So, your failure right now is that you're producing less output, like you're manufacturing less toy cars, and the cause of this is because your machines are breaking down. Okay, that's your cause. But your root cause is your lack of maintenance and machine checks. So, because you're not checking your machines and maintaining them properly, that is what has caused your machines to like work less properly and break down more often, which has ultimately resulted in the output of your factory to decrease. So, that is a root cause, the actual underlying cause. And now prevention control. So, what can you do to avoid the failure from occurring in the first place? So, your prevention control is basically preventing the failure from happening and taking the necessary measures to fix it. So, for instance, in our robot toppling scenario, how can we prevent that from happening is by placing, like distributing the heavier parts of the robot on the base of the robot so that the center of gravity is lower, which gives more stability to the robot, which would prevent it from falling. So, this is your prevention control. You're preventing it by taking the preventative actions. And after you do this, you will again calculate your RPN. You will like have new severity occurrence and detection values, and you will calculate the RPN or RPN, which is your revised risk priority number. It's a reduced value after the implementation of the preventative actions. And this is a sample of a hardware and a software failure mode. So I can quickly go through the example. So your failure mode is that the robot imbalances. The effect of this is that the robot topples, and you're like in a game scenario, in a competition scenario, what the effect would be a bit more major, that you would lose points and time, but that could ultimately cause you to lose the round. So this is pretty severe because it has like it'll impact the system by a lot because the system won't work if it's lying on the ground. Our occurrence value is 4 and our detection value is 8 because it's pretty easy to detect that your robot has fallen and it's like occurred 4 times. So when you multiply these numbers, you get an RPN value of 256, and and after we get this value, we've identified the root cause. It's that the distribution of weight at the upper parts of the robot is greater, so it's heavier, which has caused like the center of gravity of the robot to be higher, which makes it very easy for the robot to like fall over. And to prevent this, we just distribute the heavier parts across the robot's base. And once we do this and we calculate the RRP again, so the severity and the detection in this case stays the same because the failure is still as easy to detect and it's still severe. Just the occurrence has reduced, so the RRPN has reduced. And ideally, our RRPN should be 0. And lastly, I just wanted to mention that FMEA is also a living document. So it's like you just don't start it and like you're done with it and then it's over. So it's a living document. You'll keep updating it, and it's like impossible to reach 0 in a real scenario, but that is your aim. So like you keep striving for that. And your software example is the camera is unable to detect the pixel, and like you're free to read it. This one is pretty simple, so I will conclude it at that. Thank you for watching.